Equations of motion. So in this video, we'll have a look at the three linear motion equations, and they are v equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. And these are in addition to the basic ones. So velocity is equal to displacement over time, distance over time, and acceleration is equal to velocity over time. Okay, so let's get into the variables. So we've got 5 variables here. We've got v, u, a, t, and s. V is the final velocity, and it is measured in meters per second. So these are all in SI units. And u is the initial velocity, again meters per second. Acceleration, this is in meters per second to the -2. This is time in seconds, and this is displacement in meters. So what you'll have to do in a question is that you need to identify which one of these variables you have and which one you need to find, and identify which of the 3 equations you should use to find your unknown variable. It's good to see that this equation doesn't have an s. This doesn't have a v, and this doesn't have a t. So they have different uses. So let's get straight into an example. So question 6 says a book is knocked off a bench and falls vertically to the floor. It takes 0.4 seconds to fall to the floor. Determine the book's speed as it lands. Okay, so a book is falling, which means the acceleration is gravity, which is 9.8 meters per second. And it gives us the time, t equals 0.4 seconds to fall to the floor. Okay, now we need u, v, and s, and we're trying to find v, so we don't have that. V is the final velocity. Now the initial velocity. The question says a book is knocked off a bench. So before it was knocked, the initial velocity was 0. So that's 0 meters per second. So we need to use an equation that doesn't need s, but includes these 4 variables. And that is v equals u plus at. So we're going to use that equation. So we have v. V is our unknown, so let's leave it at v. U is 0 plus acceleration 9.8 times 0.4. And that's equal to 3.92. So you can say the book's speed as it lands is 3.92 meters per second. Okay, part B, determine the height from which the book fell. So we're trying to find s, and from here we can basically use any equation because we now have our v value. But let's use s equals ut plus half at squared. Since u is 0, we can get rid of this term and we substitute the known values. So acceleration is 9.8 times t, which is 0.4 squared. And this is equal to 0.784, and that's in meters. So that's part B. Part C, let's get rid of this. Okay, part C. Calculate how far the book fell during the first 0.2 seconds. So now time is 0.2 seconds and not 0.4. That's all that's changed. So we can use this equation again, s equals ut plus half at squared. So s equals half at, as the ut term gets cancelled out. A is 9.8 and now our t is 0.2. So if you put that in your calculator, you get 0.196 meters. Okay, and now part D. Calculate how far the book fell during the final 0.2 seconds. So, the first 0.2 seconds, it fell 0.196 meters, and the total distance over 0.4 seconds is 0.784. So to find the distance the book fell in the final 0.2 seconds, we just do 0.784 minus 0.196, which is equal to 0.588 meters. So that's question 6. Okay, now here's another question. A snowboarder in a race is traveling 10 meters per second north as he crosses the finishing line. He then decelerates uniformly, coming to a stop over a distance of 20 meters. Calculate the acceleration of the snowboarder as he comes to a stop. So, as he comes to a stop, meaning the final velocity is 0. Let's calculate the acceleration, so that's what we don't know. It's traveling 10 meters per second north. Okay. So, usually in these types of questions, it's handy to label your positive and negative values. So in this case, we'll call north positive. We're given displacement, 20 meters, and our initial is ms minus 1, and we don't have time. So an equation that doesn't use time is v squared equals u squared plus 2as. So let's rearrange. So we get a equals, so that's a equals v squared minus u squared over 2s. We've got v, 0 squared. We've got u, 10 squared. And we've got s, so 2 times 20 is 40. So this is equal to negative 100 over 40, which is 2.5. So negative 2.5 meters per second. Now, therefore, it's 2.5 meters per second south. We can get rid of the negative because we called north our positive value. So the opposite of a positive is negative, and south is opposite of north. Okay. Now let's move on to part B. Part B says determine how long he takes to come to a stop. So I don't remember the values. Well, actually, s equals 20, I think. V equals 0, u equals 10, and we didn't have t. And acceleration was 2.5, negative 2.5, and we called north positive. Okay, there we go. So determine how long it takes to come to a stop. So we're trying to find t now. And let's use the most simple equation. V equals u plus AT. So t is equal to v minus u on A. So that's equal to 0 minus 10 over negative 2.5, which is 4. So we can say it takes 4 seconds to come to a stop. Easy. Now, here's our last question. It's 12, and it's a pretty tough question. It says a diver plunges headfirst into a diving pool while traveling at 28 meters per second downwards. The diver enters the water and stops after a distance of 4 meters. Consider the diver to be a single point located at a center of mass and assume her acceleration through the water to be uniform. Okay, part A. Calculate the magnitude of the average acceleration of the diver as she travels through the water. So let's write all the variables down. U, V, A, T, S. it says the diver plunges headfirst into the diving pool while traveling 28 meters per second downwards. So that's our initial velocity. Okay, the diver enters the pool and stops after a distance of 4 meters. So S is 4 meters, and it says stops. So our final velocity is 0 meters per second. Okay, acceleration is what we're trying to find, and we don't have time. So it says calculate the magnitude. Let's highlight that word. Magnitude of the average acceleration of the driver as she travels through the water. Okay, so to solve this problem, we're going to use this equation. V squared, why is it red? V squared equals U squared plus 2AS. We have V is 0 squared minus 28 squared plus 2A times 4, so that becomes 8A. So this is 28. So it becomes A is equal to negative 28 squared on 8, which is equal to 98 meters per second. Now the question asks us to find the magnitude, which means just ignore the direction. Therefore, the magnitude is equal to 9.8 meters per second. So that's part A. Okay, part B, calculate how long the diver takes to come to a stop. So now we're trying to find T, and the most simple equation to use is V equals U plus AT. V is 0, U is 28, acceleration we just found, which is negative 9.8, and that times T. So negative 28 is equal to negative 9.8 on T. So T is equal to 2.86 seconds. Alright, last part, and it's part C. Calculate the speed of the diver after she has dived through 2 meters of water. So now our S value becomes halved, so it becomes 2 meters. That's all it's changed. And now we're trying to find V, the speed of the diver after she has traveled through 2 meters. Alright, sorry I made a mistake here. It's 98. So this should be 98. And time should be 0.286. Okay, now we can do this question. So we're going to use the equation V squared equals U squared plus 2AS. We're trying to find V, so V is equal to the square root of, so U is 28, 28 squared, plus 2AS, so 2 times 98, well technically negative 98, times displacement, times 2, and that is equal to 19.8 meters per second.